This is question 2 from the 2024 Pure Mathematics exam and tests our understanding of the binomial expansion. If you find this video helpful, please consider leaving a like, a comment, sharing this video, and subscribing to our channel for more content like this. This is the first part of a two-part question. Find, in ascending powers of x, the first 4 terms of 1 minus 9x raised to the power of 1/2, giving each term in its simplest form. The binomial expansion, also known as the binomial theorem, is a formula in algebra for expanding a binomial with 2 terms of the form 1 plus z raised to the power of n, where the value of n is fractional, such as 1/2, the expansion is an infinite series. That means that we can use a generalized binomial theorem formula, allowing us to expand the polynomial with 2 terms without having to perform repeated multiplications. Answering this question is a 4-step process. First, we need to recall the general binomial expansion formula before substituting values of n and z given in the question. Then, we need to expand the brackets and simplify the expression. The binomial we've been given is of the form 1 plus z, and the generalized binomial expansion for the first 4 terms of 1 plus z raised to the power of n is given as 1 plus n multiplied by z plus n multiplied by n minus 1 multiplied by z squared divided by 2 factorial plus n multiplied by n minus 1 multiplied by n minus 2 multiplied by z cubed divided by 3 factorial. We've been told to expand 1 minus 9x raised to the power of 1/2. So if n is equal to 1/2 and z is minus 9x, we get 1 plus 1/2 of minus 9x plus 1/2 multiplied by minus 1/2 multiplied by minus 9x squared divided by 2 factorial plus 1/2 multiplied by minus 1/2 multiplied by minus 3/2 multiplied by minus 9x cubed divided by 3 factorial. And this continues for further terms. We can simplify this to get 1 minus 9x divided by 2 minus 1/4 multiplied by 81 x squared divided by 2 plus 3/8 multiplied by minus 729 x cubed divided by 6, and so on, which is equal to 1 minus 9x divided by 2 minus 81 x squared divided by 8 minus 729 x cubed divided by 16, and so on. For more examples of binomial expansion, including the use of Pascal's triangle and binomials where n has a negative value, search our channel for Binomial Theorem. So, the first 4 terms in ascending powers of x in their simplest form, and the answer to the first part of this question, we get 1 minus 9x divided by 2 minus 81 x squared divided by 8 minus 729 x cubed divided by 16. This is the second part of a 2-part question. Give a reason why x equal to minus 2/9 should not be used in the expansion to find an approximation to root 3. For the binomial expansion, 1 plus z raised to the power of n, the expansion only converges towards a solution when the magnitude of the z term is strictly less than 1. For the expression 1 minus 9x raised to the power of 1/2, the z term is minus 9x. The expansion converges only if the modulus of z is less than 1, which in this case means that the modulus of minus 9x is less than 1. That also means that the modulus of 9x is also less than 1, because the modulus operation removes the negative sign. So, by dividing both sides by 9, the modulus of x x is less than 1/9. If x is equal to minus 2/9, that value exceeds the limit of 1/9. In other words, 2/9 is greater than 1/9. So x equal to minus 2/9 is outside the limit of the modulus of x less than 1/9. Since 2/9 is outside the interval of convergence, the expansion will fail to provide an accurate approximation. So minus 2/9 should not be used in the expansion to find an approximation to root 3, because 2/9 is outside the interval of convergence. Answering this question successfully relies on our understanding and application of the binomial expansion, substituting minus 9x for z in the first instance, and then our understanding of convergence and which values of x are within or exceed the limits required to find a single solution. Please follow us on Instagram, TikTok, and Threads for daily maths content.